Every app you'll ever build has to store data somewhere, and how you shape that data is one of the most foundational choices you'll make. Welcome to Data Explained. In this first episode, we're tackling the classic question, SQL or NoSQL? Two very different philosophies, rigid tables with strict structure or flexible documents that bend to your needs. By the end, you'll know how to choose. So let's frame the problem clearly. Every application, no matter what it does, shares the same basic job. Take data in, store it safely, and hand it back when asked. That part isn't up for debate. What is up for debate is the shape of that data. Do you want strict structured tables that guarantee consistency or flexible storage that bends around whatever your data looks like? SQL and NoSQL are simply those two answers. Let's start with the structured answer, SQL. The idea is simple. Your data lives in tables, like the user's table on the right, where every row has the exact same columns. You define that shape upfront, the schema, and the database holds you to it. Tables connect through foreign keys, queries go through SQL, and transactions follow ACID rules, meaning when you commit something, you can trust it actually stuck. Now flip that thinking on its head, and you get NoSQL. Instead of rigid tables, your data lives as flexible documents, usually something JSON-shaped, like this user record with a name, a city, and a nested list of orders all tucked inside one object. There's no fixed schema, so each document can look a little different. You skip the joins because related data sits right there together, and the whole model is designed to scale out across many machines. So let's put them next to each other and see where they really differ. SQL gives you tables with a fixed schema, joins between them, strong ACID guarantees, and a standard query language, but it typically scales by giving one server more muscle. NoSQL flips most of that. Flexible structures, nested data instead of joins, horizontal scaling across many machines, and usually eventual consistency under the base model. Same job, very different philosophies. Now, one thing worth clearing up. NoSQL isn't a single technology. It's an umbrella covering at least 4 distinct families. You've got document stores like MongoDB, which hold JSON-like records, key value stores like Redis, basically a giant dictionary, wide column stores like Cassandra, built for huge tables with flexible columns, and graph databases like Neo4j, designed around nodes and the relationships between them. Each one solves a different shape of problem. Now let's swing back to SQL and talk about why it's been the default for serious data for decades. It comes down to 4 letters, ACID. Atomicity means a transaction either fully completes or fully rolls back. No half-finished states. Consistency ensures your data always obeys the rules you've defined. Isolation keeps concurrent transactions from stepping on each other. And durability guarantees that once something's committed, it survives crashes, power loss, anything. That's why banks trust SQL with your money. But strength in transactions is only one side of the story. The other big question is how your database grows with you. SQL traditionally scales vertically. You make one server beefier with more CPU, more RAM, faster disks. It's straightforward, but eventually you hit a ceiling, and that top-tier hardware gets painfully expensive. NoSQL tends to scale horizontally instead. You just add more machines and shard the data across them. That scales almost without limit, but you're now managing a fleet, and that complexity is real. So when does SQL really shine? Whenever your data has rich relationships, lots of joins, foreign keys, entities referencing each other. A relational engine handles that beautifully. It's also the right call when transactions must balance. Think money, orders, inventory. Add in a stable, well-known schema and the need for ad hoc reporting across your data, and you've got the sweet spot. Postgres and MySQL quietly power a huge slice of the internet here, and honestly, they're still the right default for most apps. Now flip the coin. Where does NoSQL earn its place? It thrives at massive scale when you're spreading huge traffic across many servers. It's the natural fit when your data shape keeps evolving, or when you just need blisteringly fast key value lookups for caching, sessions, or real-time features. And when your data is naturally nested, a document that travels as one whole thing. That's where MongoDB, Redis, Cassandra, and DynamoDB each carve out their niche. Here's the twist, though. In the real world, it's rarely one or the other. Most production apps reach for both. Postgres holds the data that absolutely must stay correct: orders, users, payments, while Redis handles the fast, disposable stuff like sessions and caches. That's polyglot persistence. You pick the right store for each job instead of forcing one database to do everything. Before we go further, let's clear up a few myths that tend to muddy this whole conversation. First, NoSQL isn't better just because it's newer. It's different, and for most apps with related data, SQL is still the sensible default. Second, schemaless doesn't mean thoughtless. You're still designing a schema. It just lives in your application code now. And third, SQL absolutely can scale. Plenty of massive systems run on it, both vertically and with some care, horizontally. So let's see what that actually looks like in practice. Same question. Give me the names of users in Budapest. Express two different ways. On the SQL side, you describe what you want. Select name from users, where city equals Budapest. It's declarative and standardized across databases. On the MongoDB side, you're calling a method on a collection, passing a filter document and a projection. It works, but notice, this syntax is specific to Mongo. Switch databases and the API changes with you. Now, regardless of which side you land on, security essentials look remarkably similar. Always use parameterized queries, never build SQL by gluing strings together, or you're handing attackers an open door. Give each application its own least privilege account instead of one all-powerful admin. Encrypt data in transit and at rest. Keep the database off the public internet and back up regularly, but also test those restores, because a backup you've never restored isn't really a backup yet. With the fundamentals in place, let's put names to faces. These are the databases you'll actually run into out there. On the SQL side, PostgreSQL is the powerful default for serious applications. MySQL is the workhorse you'll see behind countless websites, and SQLite is the tiny embedded engine quietly living inside your phone and browser. On the NoSQL side, MongoDB leads the document world. Redis is the blazing fast key value store people reach for as a cache, and Cassandra handles wide column data at massive scale. So before we move on, let's pull the key ideas together. SQL gives you structured tables with a fixed schema and strong consistency, while NoSQL trades some of that rigidity for flexible documents or column families designed to scale out across many machines. Remember the shape of growth. SQL traditionally scales up with bigger hardware. NoSQL scales out by adding nodes, and that ACID guarantees remain SQL's real superpower. In practice, most production systems blend both, picking the right store for each job. So here's a quick decision guide you can actually use in the wild. If your data is highly related and transactions matter, think payments, orders, user accounts, reach for SQL. If you're dealing with huge scale and a flexible, evolving shape, lean toward a document or column store. For fast caches and session data, a key value store like Redis is the obvious pick. And if you're just not sure, start with Postgres. It's boring, it's battle-tested, and it'll carry you surprisingly far. If this episode sparked your curiosity, there's a whole Data Explained series waiting for you. We go deeper into indexes, ACID, sharding, and caching, each one building on the foundations we just covered. And if you're running Postgres in production, take a look at the database hardening course over at Dargslan.com. Courses. Your data is the most valuable thing your app owns, so it's worth learning how to lock it down properly. Before we wrap up, I'm genuinely curious. What's your default when you spin up a new project? Do you reach for Postgres every single time out of habit, or do you actually weigh the trade-offs per project and sometimes land on Mongo, Redis, or something else entirely? Drop your answer in the comment. I read them, and it shapes where the series goes next. And that's a wrap on episode 1. If this finally made SQL versus NoSQL click into place, hit subscribe. This is just the kickoff for the Data Explained series, and we've got indexing, transactions, scaling, and a lot more coming up. You can also find written companions and extras over at dargslan.com. Thanks for watching, and I'll see you in the next one.